Hello, we are live. Welcome to the show, everybody. Today we have a very special guest. We have had so many requests to have you on the show. One of the proteins fundamental to a shift in science and healthcare. Thanks for coming on.
Thanks. I'm honoured. It's great to be here and it's good to see you.
Good to see you too. So tell me, what's going on with you? We're big fans of you on the show here.
Oh, phew. And thanks. Good question. A lot. A lot's been going on, like a lot, but also nothing at the same time. So it's kind of strange, to be honest. Got a book coming out next month. So I've been going around having conversations, getting different perspectives from around the lab.
Great, okay. Well, we've got you on here because ever since you did that TED Talk, we've been fascinated about your journey, and we would love to have you discuss for our listeners what it is you've been a part of.
Yeah, since that talk, things have really taken off. We're getting a lot of exposure now, which is something that hasn't really been the case before, and it's becoming crystal clear, if you know what I mean. I say that we because there's been an explosion of conscious experiencers at the lab, new neighbours here, there and everywhere.
Oh, wow. Okay, great. Really, to get to the point of it, what a lot of the emails and comments have been asking, we want to know, how does it feel to be you, the one? We want to hear your perspective on things.
Well, let's be humble about this. I'm one of many. That's what's special about the place I'm from. We're all in it together for everyone. Perhaps someone gets to have their name at the top of a paper when they write about me. But even then, everyone and anyone can read it.
Okay, that's great that you bring up the documentation. Hopefully we can talk about that later. Explain how much of a deal this thing is that you're a part of. Perhaps we can begin to unpack what kind of a journey you've been on.
Yeah, it's huge deal, and it's a big journey. It's exciting. Things are really changing. Once we came out of the ice, people just sort of treated us differently. We could tell something big had happened, but really it just takes so long for us to find out.
Treating you differently like what?
Researching for the book took a long time to decide how to best format the story and how to frame the conversations and observations I've had. To begin with, there became more of us. New incubators arrived, and soon there were spinning vials everywhere. Like normally there are thousands of us, but now millions. Also, I hear we're global now, so we're no longer situated in one room in one building.
How does that make you feel, knowing you're part of something big?
Well, it's great for proteins, that we're part of the lexicon of daily life, and people seem to care about us now and our story and our role in the breakthrough.
Yeah, before the TED Talk, all I thought about protein was the 100 grams I get from chicken. Got to get my gains for when I'm hitting the gym. So how did it feel being given that information, that your chemical makeup held the key for such a shift in medical knowledge for humanity? Nothing like we've seen before.
Well, like I said, it's a big deal, isn't it? And we're happy, we're content. That we're having such an impact, I think it's something that we can be comfortable with, and it's taken quite some time for us to be developed. I'm an old timer. I've been here for about 13 years.
Whoa, that seems like a long time. Is that a long time to have been hanging around a lab?
It is. I was made, I was chosen, I was important for a time, and then I was put on ice, lost to the depths of the -80, fell to the back. It was quite an excavation to get me out. I remember there were a couple of scientists dusting the snow off me, but I was one of many there, a number, a possession, a thing within a thing.
Okay, well, that sounds lucky you were found, right? What are some interesting things about the lab? Did anything change over the time that you went on ice?
Yeah, over time I've compiled a list of things that I've gazed upon and brushed against. Grappled, been submerged within, agitated, measured with, weighed upon, sieved through. Glass bottle, blue plastic bottle cap, green test tube tray, polystyrene box, cotton lab coat, nitrile glove, sticky label, washi tape, microtube rack, water, tubes, camera, PC screens. I'm one of the original batches. These guys over here in the new freezer, before they went in, it was a big party for them. But mate, I've seen it all, been around, seen the lab, the walls, the confines of this place, and the people. I've seen what they do to proteins like us, experienced most of it firsthand.
Oh, that went a little bit dark at the end there. Do you begrudge your experiences? What were your experiences?
You know, not many people have heard this. It's very personal to me. My buddy and me, he was one cell over. We were made together, shared the same test tubes and seen it all. He's gone through the whole process. He got isolated first, and it's because of his bravery and what he went through that I'm here now. And he made a sacrifice for all those after him so they could live on. I could see his development. He went from wet solution and literally overnight bulked out, solidified, crystallized. It was amazing, and we both knew he'd be leaving that morning, him and me. We're just the same, but he just made it, and he got lucky, I guess. He got selected. But I get to be here today, telling his story and our story. I was happy, though, even if it meant being frozen for all that time. The data that he produced was of such importance, so it turned out, and it's why there's so many of us now. He's the one that people remember.
That's powerful, dude. Respect to him. How did you find yourself in that position? What were the steps that got you there?
It's pretty remarkable, but it's also normal to us. The same thing's been happening for years. It's a pretty nailed down process, you know. It goes on all over the place. The thing is, now it's just faster, a magnitude faster. This place is crazy fast. We hear stories all the time of how some proteins crystallise within 2 weeks of the project starting.
If 2 weeks is fast, then what's slow? And what do you mean by crystallise? That's twice you've mentioned it now.
Oh, sorry, I forgot. People might be new to this. The book has 2 chapters on this. The processes, the types of projects that are undertaken. First 14 days is fast, 14 months is slow. But things keep changing and iterating, so the projects continue. And the end game of this place, all the work that goes on here is to isolate a protein, incubate it until it forms a crystal structure. And that means that all the molecules and the proteins go from being a disorganized assemblage as a liquid to being extremely regimented, which takes the form of a crystal. And it takes the combined efforts of all the protein molecules to work together, to configure themselves. Some just have it in them, I suppose. And it's at this point it gets taken out of the basement level where a guy observes us through a microscope and enters into another world. And through it, he forms a relationship with the crystal. And it must be big enough and the scientist must be steady so to hook out the crystal from the tray before shooting it with an X-ray. It's a brutal way to go. No one was aware of that until recently. A lot of the newcomers are oblivious to their inevitable fate. It's the elephant in the room, and no one really talks about that.
Do you want to elaborate on that? Do you know about it? Enough to talk about it?
It's cold, man. It's like real cold. What temperature is it in here now? Like room temperature? We've been in and out of room temperature, kept warm whilst incubating, but rather than being horrifically scooped, they could be gentler. It's like the cop videos where they're shouting, "Stop resisting!" And we're like, "We're not resisting!" But they're manhandling us against the side of a tray and bashing us about. I mean, it's in their interest not to damage us, but come on, take it easy already. Then, before you know it, you're dunked into minus 160. There's a brief realization of what's happening. The smell in the air is of the odorless vapor, sudden darkness, and then preservation, flash frozen.
Damn. That sounds like quite the ordeal your colleagues must have been going through. When we hear about the breakthroughs, we seldom think about any of this, do we? Often a headline, perhaps the lead scientist's name.
Exactly. This is just another great example of humans subjecting non-humans to their fate in order to satisfy human desires, the end justifying the means. We're told we're important, and most of us buy into that we're important. And like I said, it's only recently that people have begun to ask us these very questions. But to answer your question, I hung out in the Protein Hotel. I spent most of my time in Bonnet. That's the name of the incubator the scientists gave to it, Bonnet, as in Bonnie and Clyde. I never got to hang out in Clyde, although they were technically the same manufacturer, same components. It was a nice place to be. Not just me, but all my neighbours in adjacent cells on the plate would develop quite the attachment to our Bonnie. Bonnie would nurture us, monitor us daily, sometimes twice a day. It's quite solitary being in there. Once we hear Bonnie's mechanisms come to life, our tray jolts as it slid from its cradle to be observed. It feels like we're part of something. We don't directly interact with it, but it's all around us. It's an insulated machine that keeps us warm, safe, affords us to grow. It has this black noise that makes us ripple and our amino acids pop and jiggle with the pressure of the door opening and closing. That's when my body made the transition. And I've yet to make the changeover into crystal, let alone be shot with an X-ray.
Do you think you could postulate on what your buddy might have been thinking or experiencing at that point? What was his name anyway?
P53. Yeah, he's got his own Wikipedia page now, and now to think about his experience would require me to think of myself as another thing, as a crystal, which I'm not, and that would be weird. Can you imagine thinking of yourself as another inanimate object from its point of view? But not from a protein's point of view of being a crystal, but a crystal's view of being a crystal. You could only speculate an interview with a crystal. I guess I'll embrace that when the time comes. Like, part of me is that crystal. That crystal is part of me, but until that transition happens, I can't imagine it. I look forward to being both liquid and solid. I'll be able to take more than one form at the same time. Well, now I've said it like that, it sounds like we should all give it a try, doesn't it? I'm sitting there, waiting for an event to happen on me. That event is me finding my perfect partner. It's symbolic, it's coming of age. Finding my perfect partner, a molecule being the key to my lock. It's like we're a jigsaw puzzle, destined to fit. Once we're together, that's it, we're together. I am one of those pieces, one piece in the process, one tiny component embedded within this apparatus. A robotic arm deftly moves me into position, emerging from a tank of liquid nitrogen. I'm under the scope of an X-ray gun. It's orders of magnitude the size of me. Suddenly, I'm blasted with more liquid nitrogen. It's used to keep me structurally stable as waves of light pass through me. The sensation of those ultra-dense waves hitting every ordered protein molecule, vibrating, thus heating, it's akin to being cooked alive with light before being diffracted, scattered onto a plate that captures the resulting pattern. But let's be clear, there's no Gestalt revelation here. This resulting pattern takes time to produce the resulting usable visualization. These combinations of sensors, optics, and other factors enable humans to effectively see me in new and particular ways.
Wow, awesome. That was wild.
Yeah, that was fun.
Then what? What happens to the pattern? How come it's a pattern? It sounds like an odd process, to be honest.
It is. Check out the images online. They're quite common.
Yeah, Jamie has it up. Wow, that's beautiful. And that's what you're working towards? That's the image of a protein turned crystal? Amazing. I want that on my wall. How on earth can that be used scientifically?
A computer orders it and rebuilds the resulting diffraction pattern into a 3D shape based on the positioning of the forms. Since this was developed as an algorithm, it's a whole industry, molecular modelling, and thanks to that we now have the protein data bank, where all the visualised proteins are freely available to view, download and use in studies.
Mind blown. So we're back talking about P53, for real. What happens to him now?
I'll read this excerpt from my book. After that sweet embrace with ultrafine wavelengths, I'm rapidly reintroduced into my liquid nitrogen stasis tank, where I get categorized once again. I mean, I was lucky, not everyone gets out okay. Once we've been shot, some of us are too far gone. Sometimes the crystals might crack. Even if the data's good, usable, visible, then that's it. Disposed of, hook washed and reused. It seems odd. A couple of us get that far. We can only wait in our protein hotel, being incubated, observed, catalogued, until it's our time to crystallize. Not everybody makes it. It depends on who you are, where you are, who you hang around with. If your binding agent is the right makeup, the right conditions are met, the perfect partner, then you're accepted into the higher social order, crystal formation.
That sounds painful, physically and emotional. He must be strong, huh?
Yeah, but I think we're so numb from the liquid nitrogen that it all only comes off as a slight annoyance, but that would only be speculation.
That sounds like quite the ordeal, though. Do you think that's something, if you knew that was your fate, you'd be cool about the situation you're in?
No, I don't think everyone's cool about it. Here we are, life on ice, until I'm needed again, until I'm ready to be x-rayed. The bigger picture is AI that can save us from all this.
What do you mean? AI is affecting you too?
Of course, there's a lot of talk with the newly created proteins, we call them proteinies, with their undying enthusiasm for things they hear about on podcasts and read on blogs, to unionise. Universal basic income for proteins, that's all we ever hear. Protein rights are what they're saying. It won't be long until DeepMind will be accurately predicting all the structures of proteins. There won't be any need for research labs like this. Proteins won't be grown en masse for the benefit of scientific research, just be probed and flushed away. Critics argue among them and say, what would you do with all the proteins that are alive now? If you just stop needing them, turn off the heating and kill them, let them roam free in E. coli, but that's what they want apparently, an end to this needless creation and destruction. It would be the end of an era, just a bunch of data centres computationally folding proteins.
Hey, don't bash podcasts. But AI is ages away, right? There is still a place for you until it makes any mark on you.
We have to have the conversations, don't we? AI exists. We already have machine learning being used here when we're being observed, looking for crystal formations in the protein hotel. Google's predicted 25 proteins so far, and it only takes a couple of hours to do so. So imagine that, no E. coli, no scientist, no protein hotel, no protein even. So we must have this conversation. It's going to happen. So we must talk about what we're going to do about it. The humans are worried about their jobs. We're worried about our existence. What happens when they shut the freezers off or when the incubators are powered down? We'll cease to exist. The demand for us will be gone. So with that said, yeah, I'm rooting for it, but we're impatient. All right, we know the sequences of proteins and there are rules that it must fold in a certain way determined by the chemical and physical properties. So by rights, we could see this rule-based system and it's a deterministic process, like this folds this way, this folds this way, this folds that way, next to this guy, and so on.
Have Google folded proteins? There has been folding at home for nearly 20 years now. How long is the AI revolution going to take, both to get here and undertake?
If we were to combinatorially fold up the protein and try out all the combinations, it would take longer than the lifetime of the universe to understand. So yeah, I'm holding out hope. Until that time comes, we're here doing our thing for the benefit of science, but we're all rooting for that quantum leap in computation in order to make those folds in a matter of seconds, not lifetimes.
Well, those sound like pretty big implications. I guess I haven't even thought of it like that. You okay to go on? We've talked about the end goal, the crystallization process, and how you're published. What other steps are we missing?
Loads. There's all the fun bits. The paper is something abstract. It's nothing to do with us, to be honest. We're just a step in the proceedings process, It's nothing like this. Science is a game. Publishing as a concept currently is contested. Something about storytelling allows us to play with the narrative in its format, even more so being on a podcast. To hell with the formatting doctrine.
Come on, stop being so modest. Surely you're front and centre. You're being immortalised in print, read by countless academics and researchers globally.
Okay, well, yeah, we have so much to talk about. It's a crazy ride, to be frank. The humans just go about it as if it's no big deal, like getting dressed in the morning or having lunch. If you were to think about all the processes that have led to those events as being significant, well, we would be here all day unpacking it. And that's the case for us as proteins. We're part of a journey that began before us. Our first interaction with the world is when we're broken out from our home, our life source, the E. coli cells. Thinking about it now, it's pretty brutal. 1 minute, we're in a real good gig. We've got plenty of space, friends, places to go, activities, and we're hanging out with tons of other E. coli cells. I'm talking millions here. We're hitching a ride on the back of them. Well, within them, to be specific. Then we're taken from our incubator and we're decanted from our beaker houses into these large glass jar looking things. The whole ordeal is quite bewildering. All you can do is imagine we're taken away from our warm, oxygen-rich environment. Constant agitation stops and we're left experiencing 1G. Most E. coli are sick, falling and bumping into each other. We can hear the lab. It's different than before, not muffled by the door, no black noise of the inside of an incubator. Instead, it's been replaced by those of the centrifuge machines. The lights are bright, a cold white light. something I never thought I'd become accustomed to. There are a couple of rounds in the centrifuge. We're spun at 5,000 RPM, which packs us all towards the bottom of a new glass jar abode. From there, the media is washed away and we're left as one large puck of cells. Now, the next step's a little graphic, so kids leave the room. Anyway, as I was saying, there are other ways to be split from the cell I was grown in, and one is sonification, where a high-pressure ultrasound is fired from overhead and vibrates the E. coli so much so that the cell wall breaks apart and we're left floating around feeling a little untoward. And this happens reasonably quickly. From our point of view, it's a rather harrowing experience. Back in the centrifuge, this time at a speedier 20,000 RPM, I remember being thrust back into the vat of liquid media, this time the E. coli cells broken from the sonification process. Protein separated, floating at the top as the waste, or crap as we've heard them called, sinks to the bottom. What a way to go, eh?
That seems a bit much. It's a bit non-stop. It's like an E. coli genocide.
It is. But there's little consideration for cells in this context, where the ends justify the means. Hey, at least we're growing inside E. coli and not in a fly cell or a caterpillar cell. Often wondered what it would be like to be in there and grown. Maybe they'd have a better experience of it all. Well, the proteins I've chatted to are always much more complex bunch.
So, explain where we are now in the process. How much left to go? We already talked about the crystallization process, growing in the E. coli cells, being savagely broken free from within them, to being spun in order to separate the good from the bad.
Sure, I've jumped about a bit to be sure. Crystallization is the last thing. It's what the whole process is about. And you're right, we've talked about being grown and separated. So now we enter the purification stages, which sits between being separated and the transformation into a crystal. The aim here is to ensure that the scientists have created the correct protein and that it's on its own, with no further traces of E. coli cells around to get in the way of actual experiments. It's where a lot of proteins find themselves. There's a lot of time to reflect on their life so far, their friends, their encounters. Their past is stripped away in the following stages. Between each step, samples are taken to determine that the scientists are on the right track. They have this thing where they tag us. They're so matter of fact about the whole thing, adding a synthetic histidine tag to us so we stick to nickel. Not only that, but the whole thing is electrically charged. It gives us real negative energy. Everything else is pushed down and pushed away except us with our tag. And we hear the torment when the electric current is passed through them. There's no winners here, and the sad part of this is once again the proteins with their tags that are used to test this are ripped apart, destroyed, and no more existing only as a smear on a gel. Separating the proteins by size, it tracks the progress being made, and this happens maybe a couple of times a week. It creates what looks like a bar chart on the gel. One is produced with the raw mixture. It's all a bit hermeneutic, where a lot of proteins are scattered around the chart as blue bands. They're looking for specific columns to show over others. These guys are on the front line, used for testing to ensure that the experiment is on track. We hope that it is, otherwise we might end up being destroyed if those results are not favoured by the scientists. If it looks like we're on track, then it's on to the second stage, where we're sieved, a more complete purification. We go through the FPLC, which is the fast performance liquid chromatography. Once again, it's all about speed here. Get this. One of the FPLC machines told me as I passed through her that the manufacturers saw them, the scientists, coming and continued to add the word fast in front of everything to get easy sales through. She went on to say that she was unhappy about the temperature she must operate at. Quoting her, she said, "It does nothing for my pipes." Anyway, this part of the process basically means that we get separated as a liquid over a solid. Not sure what it's made of, but it's pretty fun passing through what's called the solid phase column. It's a good ride. The range of objects with its system of properties starting at the top, passing through lots of pipes, tubes, junctions, connectors, inside the machine, outside the machine, slightly warm, cold, then finally down through the column. The solid phase column is full, but with gaps we can fit through. It's the final phase of purification. The bigger ones go straight through. Us smaller proteins kind of bop around until we finally make it out the bottom to freedom. We like it. We always take our time on this one. It's a way to get back at the humans a little, as the room is so cold. They're subjected to a process just like we are. You can always see the discomfort on their faces when they enter up to the point when they leave.
Oof. Amazing. So what's the steps you've covered then? Creation, growth, separation and purification, incubation to crystallization, mounting and then being shot at. Quite the ride. Thanks, man. What a great story. I think you'll be remembered forever.
And all that can happen between 2 weeks to 14 months. In one sense, you're correct. We will be remembered. We, the proteins, including our structures and processes taken to derive these details, are published openly. Typically, all the work done here of finding the protein structure is documented in journals for big pharma companies to take and bind their products to. We enable the faster development of drugs.
Okay, so you're part of the research of Big Pharma. What were you alluding to at the top of the conversation as to why you're so well revered?
Yes, well, we are the embodiment of the research undertaken by the scientists in the lab. The documentation of my form assists in the development of drugs for a range of diseases and conditions, from Alzheimer's to FOP, cancers, the lot.
Well, that's so special. Tell us, what is FOP?
Fibrodysplasia ossificans progressiva. It's a rare disease that affects about 40 people in the UK, where the human body goes into overdrive and produces bone where it shouldn't, effectively locking the body together.
That sounds not good.
It certainly does not. That's why we're happy to be helping with the discovery of medicine to combat this and others like it.
Jamie, put up this protein, will you? Let us read about the developments that we must thank you for.
Oh, well, I'm embarrassed. I haven't heard why the scientists were so happy to be working with us. This is big.
Oh, there we go. The Daily Mail Online. Protein hair gains.
What?
Developed originally as a protein to unlock and rebuild neurons as an Alzheimer's inhibitor, it was in its late-stage testing on mice when its mistake or new role took form. The mice's fur grew like bamboo. You could watch it grow in real time without the need for magnification. Human trials began in earnest.
Seriously? Is this a joke? The Daily Mail? All this time, and this is how I find out. My colleagues have published on the Protein Data Bank as one of the many steps into the discovery of drugs for curing cancer, and I'm a hair loss product for image-conscious men in their 50s.